Hello and welcome. My name is Quavel and I am a Minecraft Bedrock Redstoner and add-on creator. Here is my fourth and last part of my puzzle map tour of the Mortland mystery. I built it at the end of last year and it has some of my newest redstone ideas. It may look like an innocent Minecraft village, but each structure hides a secret. You will find all my puzzles are hidden underground. As you can see, there is a vast area filled with redstone. My first room has some basic redstone using levers and rails. If I remove a carpet, you can see that each lever controls the direction of the track below. The target is to get the minecart across the maze of rails to collect an item, and then back again to retrieve it from the chest. Here, where the item is collected, there is more complex redstone. The item is visible on this shelf, and below it is a hopper. Around this point here there is a detector rail which triggers the redstone at the back. This feeds through to the redstone torch and cuts the power to this hopper, which causes it to take the item from the shelf. Once the minecart reaches the hopper, the item instantly deposits into it. This comparator at the back registers the shelf is now empty and will trigger the powered rail below the minecart, sending it back automatically. My only regret with this room is it is a little too easy and I wish I'd made it larger. The next room I want to show you is this long room for which you need to climb to the chest on the other side. On one wall there are 12 buttons and on the other there are 12 blocks that push forward when the button is pressed. Each button operates 2 blocks, and if the block is already forward it will retract. The player has to find the right combination of buttons to get all the blocks. Note that I could have used levers, but I thought that buttons on copper bulbs was a nice effect for this room. Behind the buttons there are redstone connections leading to a series of copper bulbs at the bottom. Each line connects to 2 bulbs, giving the process that one button can turn it on and another can turn it off again. From here this is passed to 12 vertical columns of redstone torches on blocks. I found this to be the most efficient way to send a signal upwards without each column affecting the adjacent one. The top torch powers a piston behind the stepping block. Another puzzle involves setting a series of item frames to be rotated into the correct combination. So, putting a comparator behind a block with a mounted item frame will give us signal strength based on the rotation of the item. If I rotate this to position 4, I will get a signal strength of 4. The redstone torch here will be powered on for anything that's 3 or less, and the repeater here will be powered on for anything 5 or more. So I invert the output into the redstone lamp and we can see the effect. This can be compacted into this 1 block wide circuit, or this 2x2, but all have a common problem. If I want to change the value, then I need to rebuild it using a longer or shorter redstone line. Now this circuit solves that problem. The comparator has been set into subtraction mode and there is another item frame and comparator coming in from the side. This has 2 blocks of redstone dust which will reduce the strength by 1. This way, when the signal strength from both items is identical, then the side value will be 1 less than the front, and then once the subtraction has taken place, we just detect for a power of 1 to know that it's a match. To demonstrate, if I change the rotation in this item frame, then I just need to match it at the front and the lamp turns on. As the first comparator needs an input from the side, it would not be possible to rebuild this circuit in a single block width. This is the most compact I could make it at 2 wide and 3 high. If I wanted a series of these, then I would have to space them at intervals of 3 blocks so they wouldn't interfere with each other. To make it challenging for myself, my target was that each item frame was adjacent to the next. To achieve this, I had to make the build much larger. Here, the right hand frame is feeding into a series of comparators and blocks that step downwards while preserving the signal strength. At the bottom, you can see the item frame for setting the required input and the output circuit that tests for a match. The left hand frame is doing the same but stepping upwards, and the redstone for the center frame is squashed between them. By combining the output of all of these, we can determine when all frames are set correctly. I have built this 3 block wide version in such a specific way that I can place another at the side without the redstone crossing between them. This allows me to duplicate this structure and easily extend the number of item frames to any amount. Here I have placed 3 of these structures to give a total of 9 item frames. You can see I have numbered each frame both front and back, so I can easily change a combination if I needed. At this point I'll briefly show you my parkour room. Well, I call it parkour, but it's not expected to play this at speed. If you do want an extra challenge, then you can try playing it without stopping. There's no redstone, but I find it fun to play. And as with many of the other physical challenges, there's an easy option. Actually, I found this way too easy, so I added a medium option too. The hard option can be tricky, but I don't think it's anywhere near the level of many of the difficult parkour maps available online. Although I said there was no redstone, there is this tiny bit leading into this command block. This is placed behind the chest containing the award for completing the room. Now you will find this common with most rooms throughout my map, and it's a simple process that automatically restocks the chest with its original contents. This ensures the player has a way of regaining the valuable item should they lose it. Next, I shall show you this identical room maze. Unlike other mazes, the path is more visible, but what makes it challenging is that as you pass each room, you have to switch a lever to open the doors. Most levers switch the state of each door in the room, opening closed doors and closing open doors, but there are some which have a subtle different behaviour. Beneath each door is a copper bulb. The state of the bulb is read using a comparator, and a signal controls the door. The bulbs are turned on and off using each lever leading into an observer. To backtrack a little, we'll know that we can create a simple light switch using a lever and a redstone lamp. But you may have one of these types of light switches in your house, where you have 2 switches controlling the same light. This can be reproduced using observers and copper bulbs. When I toggle this lever, the observer sees the change, sends a pulse to the bulb. If I toggle the other lever, this applies another pulse to the bulb, turning it off again. I can use either lever to control the lighting. So, using this policy, I can have levers in each room, both controlling the adjoining door. In some rooms, one of these connections is broken, and in others, there is something completely different. And I didn't want to give you a tour of the village map without mentioning my favourite build. This is a secret factory area with added copper golem workers. I would love to show you the redstone behind here, but in this case it would spoil the fun for playing it for yourself. Instead, feel free to take a look around once you have completed it. For the final demonstration, I have this room filled with buttons and pressure plates, and the player has to enter the correct combination. For each correct combination, the score is increased until all have been entered. I wanted to show you the redstone for tracking the score. For each correct answer, there is a redstone signal which pushes up this redstone block, playing a note. This will also remove the power from this redstone dust. If we follow this line of comparators, which have all been set into subtraction mode, you can see that we start with a signal strength of 15 from this redstone block. When there is no other input, this remains at 15 along the whole length, and this is fed into the side of another comparator set to subtraction mode. This has another redstone block behind it. Effectively, we are subtracting 15 from 15 and left with a power strength of 0. Inside each of these barrels is a single item which produces a power strength of 1 when read by a comparator. The comparator is off when there is a strong signal coming in from the side, but once this power is removed, then this strength of 1 is subtracted from our line of 15, making it 14. When this is subtracted from 15 at the end, the result is a strength of 1, which powers this piston and reveals the first light in the sequence. In effect, I am using the comparators to add rather than subtract. Once I have completed all 4 combinations and all 4 lights are revealed, then the chest is made available to the player. Thank you for watching. This completes my series on the Mortland Mystery. Please see the fort, manor and mountain videos if you haven't already. And if you want to play this puzzle map for yourself, or wish to take a further look into my redstone, then the details are in the description. Goodbye.